Okay, in this video, I'm going to be talking about arc length. It's actually going to be section 3.2, number 3 that I start with. But I want to recap by talking about the relationship between arc length, the radial distance r, and your measured theta. And of course, somebody is like leaf blowing in the background now. All right, so here we go. So remember we discussed that theta is known as your central angle. We're going to use blue for that. So theta is our central angle. And your circle has radius r. Okay. And your theta intercepts an arc length s. Okay. So what that's describing, we have r here. Let's make that more official. R is right here. It's also going to be the same value right here. That's ugly. This thing is so hard to write with. There we go. All right, and so theta is your angle measure right here. So this is your initial side, this is your terminal side. Theta is cutting through, and then your arc length is going to be given by this outside portion. Okay. We found out that theta is actually equal to S divided by R. Hence why it's unitless. Like suppose if the units for S are centimeters and the units for R are centimeters, then those will cancel out. But we still call that radians. Okay, so 1 radian would be, remember we found out it was approximately here. 1 radian would be traveling 1 radial distance r around your circle. So kind of visually, you can think this length here is r, and this length here is r. So for this case, I would have gone 2 radians around the circle. Okay. For the second diagram, this would be 1 radius length around the circle, which would be 1 radian. Where's my, there we go. Yes. Don't know why this thing's being so weird. Okay. So the reason why I wrote it in blue is just so that you know this would still be the theta value traveled. Okay. But the relationship is that you've gone 1 radial distance around the circle. So for this, you can kind of think theta would be equal to, in this case, S would be 1, and R would be 1. Okay. So the thing is, if the radius of your circle increases, and your theta value stays the same, then your S value is also going to increase. That's going to be kind of important for us for this topic. Okay, so let me save this and clear it. And then just emphasize that from theta equals S over R. Okay. If theta is kept constant and R increases, hi, come on, it increases, then S increases. Let me make this appropriate colors. Okay. So, all right. From there, we find that S is equal to R times theta. Okay. All right, so same rules will apply. If I keep theta constant, an increase in R will give you an increase in S. All right, so let me save this. We're going to be using this formula. I've decided I'm actually going to separate the videos, so I'm just going to call this one the intro into arc length for 3.2. On to the next video.